Hey, my name is Sven. I'm from the Chair of Computer Science 5 at RWTH Aachen University, and I'm one of the main authors of the paper, Will It Run? A Playground for Testing and Monitoring Decentralized Data Analytics Experiments. In this short video, I want to demonstrate the capabilities of the presented playground by showing you how you can use our playground to develop and test algorithms for a distributed setting. To do this, we will replicate an experiment that was already presented in the paper as part of our evaluation. To be more precise, we will replicate the user study we carried out. So let's have a short recap of the use case goals and setting to have everyone on the same page. For this use case, we modeled 2 hospitals that provide data about their patients. In our evaluation, we then asked 29 participants to develop an algorithm with the goal to count the number of patients that are at least 50 years old. Let's have a look at the setting. On the left, we have the 2 hospitals that provide the data. Our goal is to develop an algorithm that first visits hospital 1, so it's sent from us, the scientist, to the first hospital, and then processes the local data. It then visits hospital 2 to do the same. We as a scientist, which you can see here, want to collect the aggregated analysis result, so we want to have the patient counts. With the help of our playground, we are able to simulate this whole flow and can therefore develop and test our algorithm without the need to execute it in a real distributed fashion. To achieve this, we need to complete 2 steps. First of all, we need to set up the simulation environment. So we need to select which data sources and data providers we want to simulate. And the second step, we need to do the actual development and testing of our analysis script. So let's jump right in. So, as described, the first thing we need to do is set up our simulation environment. This means we need to select the data sources and the institutes that we want to use in our simulation. I've opened up the first screen of the playground here, and this screen does allow us to do exactly that. If we have a completely new use case, so this means we have no data sources modeled yet, and we only gather the data source description, then we need to model the data sources first using the resource description framework as described in our paper. However, this use case has already been conducted before. As I said, it was part of our evaluation, and therefore the data sources have already been modeled, and we can just go ahead and select them. On the left side, you can see all the available data sources, and especially the organizations, and then the data holders that hold any data. Here, of our interest, it's going to be the eval organization, and here we have the 2 hospitals as described before. So we have the 2 hospitals that hold the patient data. If we click on one of the data sources, we get a visualization of what the data schema looks like. So here we can already see that it is a relational data source. We have 2 tables. One is called treatments, and the other one is called patient info. And these tables also have a relation with one another. If we open this box at the bottom, we also get further details. For example, we can see, well, this database uses PostgreSQL in version 14. It does not allow anonymous access, so we will need to provide credentials to connect to it. And we also have a description with further details. We can now select this data source for our simulation on the left. And then let's have a look at the other data source that we are going to need. So for hospital B, we can see here as well, it's also a relational data source, but it looks a bit different. It has 3 tables. And of course, we can also go ahead and select this one. You can also see here, for example, we described the ISIC use case in the paper. These data sources are also modeled here. So you have the file server with the patient information, and we have the file dump, which is realized with MinIO. And if we click on the file server here, you will see that you get a different kind of visualization because the file data is object-based. So we have different patient objects, for example, with different properties, and this is visualized here as well. And you can see for this use case, we use a total of 3 different file resources. So we use patient, imaging study, and media. And if you click on any of those, you can see, well, what's the media object like? What type of properties? What type of subproperties exist? What's the data type? And so on. However, for this particular use case, we are only interested in those two databases, so the treatment history database and the patient insurance database from those two hospitals. So you can see on the right-hand side, we have now selected those two for our simulation. And if we are satisfied with the selection, we can go ahead and specify the route via this button at the bottom. Now we can specify in which order the stations should be visited. For example, we can change the order here if we want hospital 1 to be visited first. However, for us, this does not matter, so just leave it at the default order, and we can press confirm. As soon as you press confirm, the Playground's gonna set up the simulation environment. So that's what you're gonna see in a second, and then bring us to a second screen, which is the main screen and also the main part of this video. So let's go ahead and confirm, and you will see that the setup is done and it's already finished. So now the setup is done, and we can go over to the second part, developing the algorithm. Okay, now let's proceed with the second and last step, the actual algorithm development. For this, as you have seen before, the Playground opened the second screen, which is the main screen, and this is split into two parts. You can see on the left-hand side, we have the code editor, and I will go into further details in a second. And on the right-hand side, you have the second part, which is a mixture of information about the data sources we are visiting, as well as settings for the simulation, and so on. So let's go to that one by one. First of all, the code editor. In the code editor, you have, to start off, you have two possibilities. First of all, you can create a new file, so start from scratch, or you can select one of the templates. Currently, we support 3 templates. One is Python, one is R, and one is specific to our environment. So it already has some environment setup done. But for this experiment, we are going to use Python. So let's create a new instance, or let's create some files according to this Python template. You can see 3 files have been created now. We have a main file, a Docker file, and you can see here there's a install command to install all libraries that are required in this requirements.txt file, so that we can use to install additional libraries. And the main file just says, welcome to the PADME Playground, so as a starting point. Moreover, in the editor, we can do upload. So if we already have an existing script and we just want to test it, we can just drop it here or browse for files. We can also add new files. So if we want to add a second main or another Python file or anything else, we can use this dialog, and we can download the current or all the current simulation files. And in the upload, you can see here there's the option to deflate zip files, the download functionality. So this button will download everything as a zip file. So you can just upload it again. So you can stop your analysis. I don't know, maybe you're done for the day. You can download it, and then the next day you can simply reinitiate the same simulation setup, re-upload your file, and just continue where you left off the other day. And the first option we have here, which is the most crucial one, is to actually run the current code. So if we click this, then the current code is executed in a simulated environment. But we'll get to that in a second. On the right-hand side, like I said, we have a bunch of options, with the first one being we can see the current schema. So this was already visualized in the first page of the Playground. So there we were able to see this, the schema. But of course, it's very important to have the schema doing the development as well. So we can switch here between the different hospitals. And if there are different data sets, we can also switch between those. So for example, in the Isaac use case, we had 2 data sets per station or per institution, and then you can also switch between those. You can also change the size here. So maybe you want more space for your code and less space for your visualization. Then you can adjust this, or maybe you only want a visualization. Yeah, then you can adjust this according to your needs. The second thing we have here are schema details. So these have also already been visible in the first screen. So further information about the database, like the type of database, so Postgres. So we have already seen that. Then we have an option to change the route. So if maybe during the development we realize, well, maybe we should visit hospital B first, we can change that here. And then we have the fourth option, which is the log output. So this will display the output that is generated by visiting the different stations. So we can monitor our analysis. So let's try that out. Let's press the play button. You can see here we're currently only printing welcome to the PADME Playground. Let's press play and see what happens. Now this was really quick, but you can see here, first of all, we have the output of the image build. So as we described in the paper, Docker image is built, and we have a detailed output here. So for example, if there are any errors during a build, you can investigate those here, but this will not be relevant for us further, so we can just filter this out. And then you can see that the hospitals are visited one by one. So we first executed hospital A, we then executed hospital B, and you can see, well, our Python script was executed as expected, and we just printed welcome to the PADME Playground. We have two more options, so we can see file system changes. This will be relevant later, and also environment variables, so this will also be relevant later. So let's start with our analysis script development. If you go back to the schema page, maybe with hospital A, and go to the details, you can see it's a Postgres SQL database. So hospital B also uses Postgres. So the first thing we want to do is to install our dependencies for Postgres, and for this we want to use a very well-known library. Let me paste that into here. So that's a library name, and we will use that to connect to our Postgres database. So let's run it again and see if that works, maybe with build output. So we can see it's installing the library as expected, and this script still runs through perfect. Now we might want to connect to the database to execute our analysis. So here we have the hospital A first. We have the patient info table. You can see here we have a age column. We might want to use that age column to find all the patients that are at least 50 years old. So how do we connect to the database? Well, for that we need some information, right? We need the host name of the database. We might need a username and a password you might have seen before. This database requires us to authenticate. Well, there's a lot of information already provided by the playground, and this is provided via environment variables. You can see here we have some predefined ones. Predefined means here simply these are environment variables that have been automatically generated by the database plugin. So in this case, you have a Postgres plugin, and this created already 5 environment variables. For example, it created one for the host, the port, the password, username, and we also have one for the name of the current station. So maybe let's try to read those in. I've already prepared some code for that. So let's paste that here. So you can see, first thing we want to do is read environment variables. So we want to read in the username. You see that here. So this is user for hospital A. It's also user for hospital B, but you can see the password is different between those two hospitals. Of course, we also need the password. We need the host name. So this is Postgres in this case, and we need the port. Why do we do that with environment variables? Well, if you execute your analysis at the local, for example, in a real hospital, of course, the username might not be user and the password will not be this specific value. And with environment variables, you have the opportunity to configure your script to any target that has the same structure. Okay, so let's try to connect to the database. For this, I have also prepared some code. So with this library, this is how you connect to a database. First of all, we need the database name. You can see that here. The database name is PatientDB. So we use this connect function. We connect to PatientDB with our users, our host, our password, and our port, as read in from the environment variables. So if the connection is successful, then the code will just execute, and otherwise it will throw an error. So let's try out and print maybe a connection successful. So let's try that out and print. Okay, seems like we were able to connect at both hospitals. Cool. So let's write our query. We can go back to the schema and see, well, like we've seen before, the table is named patient info. We have an age column. So how you do that with the library is you create a so-called cursor. So we create a cursor, and that cursor can be used to execute a query. So here we can enter an SQL query, and then we use this function which is called fetch all to fetch all the results. So maybe let's print the results. Of course, we want to print result. And well, what's the SQL query? Well, let's select all entries from patient info. So that's our table name. And of course, the age should be at least 50. So we want to select all patients where the age is at least 50. Let's try that out. Cool. So at hospital A, that worked just fine. At hospital B, we were able to connect, but we got an error. And it says something about, okay, undefined table relation patient info does not exist. So it seems like patient info does not exist in hospital B. So let's have a look at the schema. Hospital B. Aha, here is a different table. So it's named patients and not patient info. So what we can do is we can adjust our algorithm and use different queries according to which station we are currently visiting. So we can have a look at the environment variables section again, and you see we have a variable called station name by default. So let's read that in as well. So station name, and we want to read that in from OS environment. This is the environment variable name. Maybe let's print that as well, station name. So then we can see, and let's do a check here. So if station is, well, hospital B is different. So let's see the value of hospital A is hospital A. So if that's the station name, then execute this query. And otherwise, let's do result 5 to see if it works, and then we can come up with a query for station B as well. So let's execute again and see. I made a mistake. Of course, the variable here is called station name and not station. So let's try that again. Cool. Okay, successful connection. We already also got the results here. Hospital B was also connected, and we got a 5 here. So let's copy. Maybe let's do this, because we could need this all the time. And only change this execute part to a different query. So have a look at the schema again. We can see hospital B, it's called patients. Okay, let's try that, patients, and execute again. Nice, that worked. So our query is already done. Now we need to store that in a file as well. And we also want a count. So maybe first of all, the count, you can simply get that by determining the length of the result. So the length of result. And now we want to store that in a file. Of course, I've also prepared some code for that. We were gonna name the file result.txt. We're gonna append, because of course this is executed at 2 stations. So at the second station, the file already exists, and this will create a new file at the first station. And we simply write, well, the name of the station, and then the patient count, so the number of patients. Maybe let's print the patient count here as well. So we can compare, and let's execute that. Again, here I used station and I named the station name here. So let's try that again. Okay, so it seems like we have 5 different patients at hospital A and 7 at hospital B. And now we can also see the last part, the file system changes, where you can inspect which files have been modified, added, or deleted during your execution. So here you can see there's one file, result.txt. It has been modified because we aggregate the results here. So yeah, in the first station it's created, then it's modified. So the overall global state is modified. And we can download it here, or we can download the whole user folder. And we can also have a look. So you can see hospital A, 5 patients, hospital B, 7 patients. So our analysis script worked successfully, and we were able to find problems like, for example, this schema difference. Otherwise, this would have caused another execution of the code in the real environment involving multiple people. But luckily to the playground, we were now able to get the code right in the simulation, and now we would be able to distribute it to real hospitals. Now, the only part that remains for this video is to conclude what we have seen today. We have seen how you can use our playground to set up a simulation environment and then leverage this environment to develop and test algorithms for a distributed setting. Although the use case we presented in this video was pretty straightforward, the same idea and approach also apply to more complex scenarios, like, for example, a model training algorithm for machine learning. Overall, we would like to thank you very much for viewing this video and showing an interest in our research. If you have further interest in the playground and maybe even try it out yourself, you can find the GitHub link on this slide, and probably you also found this video already in our repository. In GitHub, there are further instructions how to set up an instance of the playground locally, and you can also find all the models for the use cases. So for the ISIC use case and the use case we presented today, to just set up the playground like I've presented to you today, and then to play around with it yourself. Thank you very much, and bye-bye.